So from the assignment sheet, we're going to take a look at number 1 and number 4. And I'm going to start with number 1. And the common question is, how do I get started with these? So there are a couple of things that you should already have in your inventory. And I'm going to come down here and just write some things. And one of them is the Pythagorean theorem, sine squared plus cosine squared equals 1. So that's called a Pythagorean identity. And I don't have them memorized, but I know there's 2 more. And the first thing I'm going to do is divide everything by sine squared. So if I divide by sine squared, that's going to give me a 1. That gives me the cotangent squared. And 1 divided by sine squared is the cosecant squared. So I get those pretty quick. If I divide everything by cosine squared, I'm going to get tangent squared of x plus 1 equals 1 over the secant squared. So part of my identities that I'm going to use to prove an identity, I'm going to start with the Pythagorean triples. Other information, I have my tan equals sine of x over cosine of x. And I want to remember that the cotangent of x is cosine over sine. And I also have the reciprocal ones where like the secant is 1 over the cosine, etc. So keeping a bunch of these identities handy is going to help me to solve these identities up above. So what do I need to do? I need to pick a side. Pick a left side or pick a right side. Left side looks fairly complicated. Right side's a little cleaner. So I'm going to pick the left side. Now, another note that I could put down here in the bottom is I noticed for this identity, on the left side, I have 2 terms. On the right side, I have 1. So if I need to change the left side into the right side, one of the things is I need to combine these. And in order to combine them, I need to get a common denominator. So if I take a look at this first one, I'm going to multiply the first term, okay, by secant of t plus 1 over secant of t plus 1. And on the second term, I'm going to multiply by secant of t minus 1 over secant of t minus 1. So it got a little sloppy there, but let's see what happens when I clean it up. This left one is going to have the denominator of secant of t plus 1 times secant of t minus 1. And I'm going to have the same over here. Secant of t plus 1, secant of t minus 1. And again, I'm working on, I notice there's 2 terms here, and I have 1 term in my answer. So I want to combine them. In order to combine them, I get a common denominator. My numerator, secant of t plus 1 times 1, is just the secant of t plus 1. Over here, I get secant of t minus 1. All right, so let's see what happens next. If they both have the same denominator, I can now combine them. Secant of t plus 1, secant of t minus 1. Secant of t plus 1 plus secant of t minus 1. Well, a banana and a banana, that's 2 secant of t's. Plus 1 and minus 1 cancel each other out. Taking a look at this denominator, I have the product, I'm multiplying, of a sum and a difference. So if I multiply those, my numerator is still going to be 2 secant of t. My denominator is going to become secant squared of t. Outer and the inner cancel, and I get a minus 1. I like that. Because if I look down at my identities, I have the secant of t here. If I subtract 1, secant squared of x minus 1 becomes the tangent. So now this denominator here becomes tangent. So I have 2 secant of t over tangent squared of t. Still with me?
Yes.
Okay, good. So let's see what I have here. I have secant of t. I kind of tired of working with the secant of t, but that's okay. I do know secant of t is the same as 1 over the cosine of t. And I know tangent squared is sine squared of t over cosine squared of t. So we're bringing a lot of our algebra skills back into play. Now, to divide is the same as multiplying by the reciprocal. So this is now going to become 2 times 1 over the cosine of t times the reciprocal of this, cosine squared of t over sine squared of t. Again, these are easy to watch and easy to follow, but I do know they are hard to do. Next step, I'm going to cancel cosine of t from the numerator and denominator. And what do I have left? I have a 2, I have a cosine of t, and it's over sine squared of t. I have a 2. I'm going to take the cosine over the sine, which I know is cotangent of t. And I'm going to be left with a 1 over the sine, which I know is the cosecant of t. And that's where we were trying to end up. A lot of problems that folks have is where to get started. And again, hopefully that hint of I have 2 terms, I need to combine them into 1. So I decided to work with the left side. Got the common denominator, nice and slow algebra skills. Still algebra skills, still algebra skills. Okay, now I used an identity here. Said, I want to change this and I want to change it to tangent squared. And then I used a bunch of trig stuff after this to finish it up. And let's take a look at now. Now, is this the only way to do this problem? No, there's a bunch of other ways, but this one is what came to me. So if I look over on the next page at this one, I see, oh boy, a whole bunch of mess. And nothing's really jumping out at me yet. But I think what I'm going to do is, this is another option, go right into converting tangents and cotangents on the left side into sines and cosines, because I'm more comfortable working with that. So now I have this big mess. I'm going to have sine of x over cosine of x minus cosine of x over sine of x divided by sine of x over cosine of x plus cosine of x over sine of x. Now this goes back to an old-fashioned algebra skill. It's dealing with fractions inside of fractions. And if I'd like to clear the denominator of all of these, I'm going to multiply by the same thing. I'm going to multiply by what's in the denominator. So if I look at this and I want to multiply both terms by something so that I can eliminate the cosine and I can eliminate the sine by canceling, I'm going to multiply both of these by cosine of x, sine of x. And again, if I do it to the top, I'm going to do it to the bottom. because cosine of x over sine of x times sine of x over itself, that's the same as 1. So I'm multiplying by 1 and I'm not changing the problem. But when I distribute here and I distribute there, sine of x over cosine of x times cosine of, the cosines cancel. I'm going to be left with a sine squared. If I multiply by the second term, the sines cancel, and I'm going to be left with a cosine squared. Distribute in the denominator. Cosines cancel. I'm going to be left with the sine squared of x plus, if I distribute, the sine of x's cancel, and I get the cosine squared of x. Pythagorean, there it is. Sine squared of x minus cosine squared of x, because sine squared plus cosine squared is 1. Now, I'm really close to what I need. And did I copy the problem down wrong? I'm betting this is supposed to be a 2 inside of here. Now, in this answer, I have cosines. Down here, I have a sine. But I can replace the sine. If I come over here, another way of writing the sine squared of x would be, if I subtract that, I would get the sine squared of x equals 1 minus the cosine squared of x. So it's an identity off of my Pythagorean identity. Replace the sine with 1 minus the cosine. So now I come up here and replace it with 1 minus the cosine squared of x. Combine like terms, 1 minus 2 cosine squared of x.